Hi everyone, and thank you for joining Datadog Detect to hear my talk, The Goldilocks Approach, Finding Detections That Are Just Right. My name is Roddie-Fonseca, and I am a Senior Detection Engineer here at Datadog. We're going to go ahead and get started. I want to talk to you about some concepts traditionally that came from a machine learning data classification background. So there's going to be some terminology that may be unfamiliar. But I'm going to go through these concepts and then I'm going to show you their application to detection engineering. So to start, we're going to look at precision. Precision is the fraction of relevant instances among retrieved instances. So out of all items the model identifies as relevant, so let's say alerts, how many were actually relevant? So this is the quality of positive predictions or our true positive rate. Then we're going to look at recall. Recall is the fraction of relevant instances that were retrieved. So out of all items that were relevant or true positive or positives, we'll say, how many were correctly identified? So it's about the model's ability to find all relevant cases. So we want all true positives, no false negatives, right? And these two concepts kind of work in combination to give us our accuracy, which is the fraction of instances that were correctly classified. So out of all the instances or events in our case, how many did the detection correctly classify? So it's a measure of overall correctness. So we want, this is great. This is low false positive, high true positive. Let me rephrase this now because again, we're talking instances, relevant, retrieved, models. Maybe this is very unfamiliar. So what do these concepts look like when it comes to detection engineering? Well, precision, we can rephrase as the fraction of relevant malicious events, so true positives, among all events matched by a detection, both true positives and false negatives. Sorry, true positives and false positives. So higher precision detections create fewer false positives. Great. So we want our detections to be high precision. We also want our detections to be high recall because recall is the fraction of relevant malicious events that are detected. So out of all activity, there's a subset of malicious activity, and the recall is how much of that malicious activity was detected. So high recall is fewer false negatives or less missed malicious activity. So we want high recall and high precision. We also want high accuracy, where accuracy is the fraction of correctly classified activity among all activity. So we want true positives and true negatives, and we don't want false positives or false negatives. So high accuracy detections detect the majority of malicious activity without generating false positives. Okay? So I'm going to give you the mathematics of this. Some people are going to tune out now, but this can help understand these concepts more. And also you may be able to implement these metrics. Now, some are harder to implement, but we'll talk about that. First, we have precision. It's very easy to calculate precision because this is our true positive rate or our false positive rate if you reverse it. Precision is the number of true positives out of true positives and false positives. So out of all detected activity, how much was correctly detected? Right? This is easy to calculate when your security analysts classify detections, alerts as true positive or false and negative. You can calculate, or true positive, false positive, you can calculate how many are true positive. Now, recall is the number of true positives, but out of the malicious activity, which is the true positives and the false negatives. Now, this is harder to calculate because false negatives are essentially an unknown. Now, you may say there was an incident that detections missed, and this detection should have caught it, so that's a false negative. But it's really hard to say with 100% certainty that there's a specific number of false negatives, because if you missed it, you don't know. Right? And lastly, we have our accuracy, which is the number of true positives and true negatives. So everything correctly classified, whether it's malicious or not, out of all the data we analyzed. out of what ends up being our true positives, true negatives, false positives, and false negatives. Again, harder to calculate because you have to know your false negatives. You have to know what you missed, which if you missed it, you might not know you missed it. So when we're writing detections, what's the goal of a detection engineer? Is it precision? Is it recall? Is it accuracy? And really, the goal of a detection engineer is for a perfectly accurate detection. Something being perfectly accurate would mean that you caught everything that was malicious and you caught nothing that was not malicious with a detection. But in reality, this is practically unachievable. We'll see some examples. You could do an indicator-based detection, but those aren't necessarily efficient. So when we're talking about behavioral detections, we want something that is perfectly accurate. While that is unachievable, we can find a middle ground. So let's visualize these concepts and apply some examples to understand more in depth why this is unachievable. So starting with recall, what would perfect recall look like? Now, let's say that this detection, or let's say all these events are registry persistence. So you have some benign events, system administrators installing software and adding persistence, or an application itself, running at start. There might be registry activity and it's benign. But you might also have threat actors establishing persistence in the registry and making malware execute on boot. So a perfect recall detection, so this circle, if that's our detection, we could say alert on every single registry persistence event. So all the keys that could lead to persistence tell us if one of those keys are modified. That would be this detection. Now, this is great because anytime a threat actor establishes persistence via the registry, we're going to catch it. But in order to do that, we've also said that anytime anyone legitimately uses the registry for persistence, our security team needs to respond and determine whether it's a true positive or false positive. And that's probably not feasible in terms of false positive rates. Your team doesn't want to be reviewing as much benign activity as malicious activity. Okay? So in this case, we want to be more precise. We want to get less of those false positives, and we want the majority to be true positives. So when we do that, let's say we say the persistence is established to execute a payload called malware.exe. Now, when that happens, we say, yes, absolutely, that's malicious activity. The payload's called malware. That's not legitimate activity, so it must be a true positive. And we see that in this case. There's no false positives. We know that those events are malicious. But I'm not going to go into Pyramid of Pain and summoning the pyramid. I highly recommend you research it. But basically what that says is that since we are basing this off of a file name, and a threat actor can easily change a file name, that there's likely to be a ton of other malicious activity at some point in which this detection would not work. So yes, we're only catching true positives. Our security analysts are happy because when they get paged about these alerts, they know it's bad. They know there's not going to be benign activity captured. But we're doing that at the risk of missing anything where persistence is established by a threat actor without their payloads named malware.exe. Okay? So hopefully you see the problem here with perfect precision and perfect recall. We can be perfectly precise. Great thing is no false positives. Bad thing is we miss stuff. We never want to miss stuff. Perfect recall, again, great because we catch all the malicious activity. Bad because we're sending our security analysts in circles. So we need to find a middle ground. So middle ground might be that the registry key was created from the command line using specific arguments, and it's specifically the run key. So now that removes anything where a system administrator is using the registry editor UI or an application is installing this. And you're left with maybe a script that runs from a sysadmin that uses the command line and that registry key. You capture more malicious activity now. Here's some ones that weren't executing malware.exe. And so we've captured more, but we're still kind of missing stuff. It's not great to miss stuff. But what are our alternatives? Flood the SOC with false positives? Or, what's our alternative to not flooding the SOC? We're going to reduce our scope and end up with true positives. So this is why I kind of called this talk the Goldilocks approach, because, you don't want too broad. You don't want too narrow. You want something that's just right and is tolerable in terms of what you're going to detect. And we can write other detections to capture this. Maybe there's a second set of registry persistence behaviors that would capture these hypothetical activities. So we can combine detections. But we also don't want to have to cherry pick and say, okay, malware.exe or this or that. And suddenly you have 20 detections that need maintaining and monitoring that each will probably still have false positives to some extent. And it's just not feasible to cherry pick right detections so narrow and so many detections to catch all the activity. We need behavioral detections that are hard to evade, but those come with the risk of false positives. Right? So the unfortunate reality is that we're dealing with what in data classification or machine learning would be a high base rate. What that essentially means is that it's not going to be this pretty division of 50% malicious, 50% benign, and you're just expanding and narrowing and capturing more or less false positive. In reality, for the majority of organizations, hopefully your organization looks like this, where you're going to have a sea of benign activity. So maybe daily registry persistence is established via regular methods, but occasionally a registry persistence event pops up in here. Again, we could cherry pick and say, well, that one was malware.exe and this one, wasn't malware.exe, but it was a specific parent process with very specific command line arguments. And we could write 7 detections that capture all that. But what happens when, that very specific detection is evaded? Because to be specific, you are likely going to use indicators that are easily evadable. And now you have another activity that pops up and you can't catch it and you need another detection. So again, we can't just play this game of whack-a-mole with these detections. We do have to make them more behavioral to be effective, but you're having to capture them within a sea of benign activity. So that's where the major challenge is. So leveraging these concepts, how do we use these concepts to find that middle ground? The first thing you need to do is understand your organization's tolerance for false positives. Depending on who you are, what your middle ground is going to be different. Because if you're in a very small business where your security team is a guy who half his time he's doing sysadmin work or projects related to security. He's a security engineer, but he also triages alerts on the side. That one guy is not going to be able to handle a high rate of false positives. Okay. Let's say we're getting 50 false positives a day. So if you have 50 false positives a week. So if you have one guy who's triaging security alerts, that one guy has 50 false positives in, let's say, a business week. Now, if you're a large organization and you have 25 security analysts in a SOC and their job 24/7 or during business hours is solely to triage security alerts, they don't have other engineering work or things like that, then now 50 alerts a week becomes 2 alerts per person. 2 false positives per person. That's pretty tolerable. 2 false positives per day per person, or per week per person. Easy peasy, they can handle it. So all this to say, there is no perfect number that applies to all organizations. You need to figure out what your tolerance is. And we create this feedback loop with our incident response team. We check in with them. Hey, what's the false positive rate like? Is this bearable? Do we need to tune some alerts, etc.? The second thing is to use historical data. If you're using a SIM and you have your detection rules, maybe your SIM has a feature, or even just using search, you can look at the existing data and understand how a rule will perform. So you could search all registry events and, oh, look, this is like 1 million events. Not feasible. Okay, well, what if I add a filter for parent process? Okay, well, now I've narrowed it down, to 100 events. Is there some malicious events I know or some command line arguments I see that I could exclude? So use that historical data and tune. And then continuously monitor your rule performance. Just because a rule is low false positive now doesn't mean something in your environment won't change to make the criteria detect on more normal behavior. So create a dashboard or run monthly or weekly metrics and understand how are specific rules doing and do those specific rules need tuning. And then lastly, determine the impact of tuning a rule. And what I mean by that is that if I'm tuning a rule for a very high impact thing, so maybe it's data exfiltration, bulk data exfiltration, if I start doing heavy tuning on that and narrowing the scope too much, the impact is great because if I miss that activity, the impact that it has is severe. But if we're talking about like a low severity reconnaissance based alert, if that has a high false positive rate, I can tune it with more wiggle room because if I miss something, the impact is not going to be as big. I can probably catch further attack activity further in the kill chain. So just think about if I tune this, what will I miss? And if I miss that, what is the impact to my organization? So I just want to show you some examples of this in my day-to-day work. Now, this is not a Datadog pitch. Hopefully your SIM has a feature like this, but in Datadog Cloud SIM, we can run historical jobs. So we can run a detection rule against historical data. So I was writing a rule for repeated connections to a block URL, see if we could see C2 traffic essentially. And I wrote my rule and it had 7 hits, which over a month, acceptable false positive rate for our org. However, there was known malicious activity from a recent incident that I didn't see in the results and expected. So I went back to the incident activity. I saw, okay, this is why I missed it. I adjusted my rule and now it has 28 hits. And so those were true positive, but it was still too many false positives for me to feel comfortable putting this into production. So then I did some tuning. I excluded certain things. I reran the job, adjusted the threshold, and ended up with 13 results, the majority of those being malicious activity related to some known activity, some were duplicates. And the false positive rate was low enough that I feel like my incident response team would be happy with the false positive rate. So you see, I went from 7 to 28. So this was too narrow. This was too broad. This was just right. One other thing to mention about how I do this in my day-to-day with Datadog when it comes to tuning is creating suppressions. Now, you might not have things called suppressions, but you might have tuning methods where this is still relevant. Something might be happening in your org. Maybe there's some migration activity or a service account temporarily being used for something that it wasn't before. And you have a bunch of rules where this would cause things to start firing. Maybe you saw it start firing. We can add a suppression that eliminates a certain subset activity. We can even set an expiration. So maybe this is just related to a month-long project. So we say for the month of October, don't trigger any detections for any rules where the service account is this or the AWS account is this. Okay. When you are tuning a rule, though, just like I said in the last point on on our list of things to consider, is when you make a suppression too broad, you're introducing risk, and you need to determine whether that risk is acceptable. Is the number of false positives you're eliminating worth the potential activity or miss? So that's something I'll always keep in mind while tuning. Okay. So that was my talk. I want to conclude this, wrapping up one of the key points that this talk was supposed to get across, which is detection engineering is hard. Okay? When you create rules that are too broad, your security team is going to be mad at you, your response team, because the false positive rate is high and they're getting burnt out. When you create rules that are too specific, you're going to miss something. A security incident is going to happen. And the management is going to be asking you, why did we miss this? Why was there not a detection for this? So this is not an easy task to accomplish. My point today was to give you some concepts to think about and ways to visualize when you're writing rules, understanding that there's not a way to make a perfectly accurate rule while efficiently detecting attacker behavior, but that we can find a middle ground and do our best. And maybe we missed something. Maybe on occasion our security team is burnt out, but we're going to continue to learn and adjust and learn our organization too. It's a lot about learning your organization. So thank you for attending my talk, and I'm passionate about this topic. Would love to discuss it more.